We are really excited to share this new tool with you that helps us tell the story of the Rangeland Monitoring Network and explore the data in an accessible format. The StoryMap production was funded through 2 USDA NRCS Grazing Lands Conservation Initiative grants in partnership with the North Coast Soil Hub and led by 2 of our wonderful staff, Mel Preston and Alicia Herrera. Data analysis for the StoryMap was led by our RMN team, including Sophie Noda, Dr. Erica Foster, Mel Preston, Ryan DeGaudio, Haley Strom, and Krista Finucci. This data has been collected by over 20 Point Blue partner biologists and field technicians who are skilled botanists and avian ecologists who also happen to be good at soil sampling. We would really like to express our gratitude to all of our rancher partners who have opened their gates to us, allowing us to collect ecological data on the land they steward to check up on the health of California's rangelands. Without their partnership, we would not have such an insight into the millions of acres of privately stewarded grazing lands in California. That's what makes RMN unique, a voluntary program designed to collect data and measure ecological function on private lands. RMN is a network of land stewards and scientists working together to improve rangeland ecosystems through science-based conservation planning and on-the-ground action to benefit wildlife, people, and working landscapes. Over the last 10 years, our team of partner biologists and field techs have worked with ranchers on over 140 ranches in 28 counties in California, covering over 200,000 acres. Our work takes place in 4 ecoregions: the Sierra Nevada and Great Basin, the Central Valley of California, the foothills of the Central Valley and coastal mountains, and the Coast Range and coastal prairie. Before passing the mic to my fellow colleagues, I'd like to highlight that over the past 10 years, our data set shows that while carbon stocks overall have declined during drought conditions, California's soils still store vast amounts of carbon, that with the greatest amounts in cooler and wetter regions. We've also observed a plant community of non-native and native plant species, and that grazed landscapes reduce encroachment of invasive plants and promote native plant populations and increased species diversity. And our biologists have recorded over 248 species of birds utilizing these private ranches during the breeding season. These grazing lands are critical to protecting biodiversity and supporting wildlife in human communities across California.
Next is measuring ecological function, which helps explain how we measure and interpret soil, plant, and wildlife metrics. If you scroll down, you can toggle through each subsection to learn more about the monitoring protocols, types of data that are collected, and a depth of information about these metrics. The Monitoring Change Over Time section walks through an example of how RMN data can be used at the ranch scale. The slider tool provides a visual example of what we might observe in a degraded landscape, such as high levels of bare ground, compacted soils, or high cover of invasive species, versus some of the things we may observe in a healthy or restored landscape. This may be familiar to RMN participants who have received a landowner letter from a Point Blue partner biologist that details specific changes over time on their property in the context of their ecoregion. This leads into the next section, which shows a table of the most common conservation practices we recommend and how they connect directly to different RMN metrics. In the case studies section is where we can learn about specific partnerships with RMN. So the 3 stories here come from demonstration ranches, and we're really excited to build this section out more in the future to showcase what we've learned or highlight specific projects on different properties. If you're a rancher who would like to share about your partnership with Point Blue or how your stewardship has evolved, we would love to work with you to get it shared on this map. And now I'm going to pass it over to Erica Foster, Point Blue's Director of Soil Research and Conservation, who will be covering the next sections.
Thank you, Krista. We're happy to be here celebrating a decade of data and partnership. My soils team and I, especially Dr. Lisa Ish, have contributed to the interpretation of the below-ground data set over the past decade. As Bonnie mentioned, we have experienced declines in the total amount of carbon stored from 0 to 40 centimeters across the network. Our ranch carbon stocks demonstrate the diversity of soils across the state, as the amount of surface carbon ranges from 4 all the way to 60 metric tons of carbon per hectare. That's up to 24 tons per acre. And then if we go down another foot from 10 to 40 centimeters, we observe stocks from 15 all the way up to 230 megagrams of carbon per hectare, or up to 90 tons per acre. Across our network alone, this amounts to 2.6 million metric tons just in the surface 10 centimeters. In the first graph here, we are analyzing the soil organic carbon stocks, the amount of carbon per area, to 10 centimeters. There's quite a bit to digest here, and it's all described in the text on the left. And the take-home message is in orange along the bottom. Soil organic carbon stocks are declining across all 3 regions, most significantly in the central California foothills and coastal mountains and the Coast Range region. You'll note that along the x-axis we have growing seasons 1, 2, and 3. This ranges from 2014 to 2022, and notably growing season 1 and 3, the summer and fall of 14 and 21, were some of the most extensive cases of exceptional drought across the state. Overall, you'll also notice that the Coast Range contains higher surface soil organic carbon stocks, and you can keep scrolling to find out why. Primarily changes in precipitation and higher temperatures that alter plant productivity and carbon inputs below ground, as well as decomposition rates and carbon losses. That is why the Coast Range has higher carbon stocks. Higher precipitation leads to productive plants, and cooler temperatures allow for retention of carbon, slowing decomposition almost like a refrigerator. Although there is not a management that can magically increase our precipitation or change atmospheric temperature, if you keep scrolling, we have a few recommendations for increasing and maintaining carbon and soil health for you to explore. I'm sure many of you are familiar with these, such as keep the soil covered, minimize disturbance, encourage diversity, maintain living roots, and integrate livestock. These practices also serve to maintain healthy soil structure, which our network measures via bulk density. The final graph of this section examines soil compaction via a measurement of dry soil weight over soil volume, which relates to water storage and movement through the soil. Overall, as bulk densities decline, we see less compaction and improvement in soil health. All of these compaction indicators are within the healthy range ideal for plant growth. So with that, this final soil figure, let's now take a look at our vegetation data.
The California rangelands we work in are dominated by non-native annual grasses such as ryegrass, oats, and bromes, which provide important forage for livestock. Here on the Vegetation Data tab, you can see the top 10 species in our data set, 9 of which are annual grasses. In contrast, most plant diversity on these rangelands comes from native forbs, or wildflowers, including rare and endangered species found across the grasslands, vernal pools, coastal prairies, oak savannas, and oak woodlands in which we work. You can see photos of some of the native wildflowers that occur on our RMN ranches by scrolling down. We have observed over 1,000 plant species across the network over the past 10 years of RMN, from 717 points on about 140 unique ranches. Down here, you can see how functional group cover has changed over time among the ranches who have been monitored 3 times, starting in the first few years of RMN. Functional groups are helpful categorizations because they group plants based on how they function on the landscape. For example, perennial grasses have deep roots that retain water, store carbon, and stabilize soils, whereas annual grasses have relatively shallow roots and complete their life cycle in one growing season. Annual forbs and perennial forbs are wildflowers. Their seeds are long-lived in the seed bank and germinate when the conditions are favorable for survival. Forbs on rangelands are crucial forage for pollinators. Legumes are our friends in the pea family, and they play an important ecological role by fixing nitrogen. Sedges and rushes have a similar function to perennial grasses, but they typically are limited to wetter locations. Across our network, we observe declines in 3 widespread invasive species: yellow star thistle, medusa head, and barb goatgrass. These declines are likely driven by a combination of active management, including invasive species control, prescribed grazing, and prescribed fire, and natural disturbances such as wildfire, and are expected to improve forage quality and plant diversity. If you have received a landowner letter from us, you may be interested in knowing more about the plants in your region. From the vegetation data page, you can click on your ecoregion to find the top 10 plant species, as well as plant functional group cover in your region. Our ongoing and future analyses of RMN aim to better understand vegetation patterns and the drivers of plant community change across the rangelands we study.
California's rangelands are helping buck national bird declines by providing vital habitat. We've recorded an impressive 248 bird species across California's rangelands. Even better, many of our key oak woodland and grassland birds are holding steady or even increasing in number. These are especially positive results considering that bird populations across North America, especially grassland birds, are declining at an alarming rate. A 2019 study estimated that the continent has lost nearly 3 billion birds since 1970, or a quarter of the total bird population. While California's rangelands can't reverse these national trends alone, our data show they're playing an important role by offering vital habitat across vast working landscapes. The bird data page of our StoryMap shows the top 10 birds in our network statewide. The most abundant bird is the oak titmouse, shown here in the image gallery, and you can scroll down to see the list of species written out. These top 10 data come from 2,375 points on 174 transects, and they represent a decade of bird survey efforts across the state's rangelands. However, bird communities vary quite a bit by ecoregion, and if you have received a landowner letter from our monitoring program, you are most likely interested in knowing more about the birds in your area rather than the whole state. From the bird data page, you can click on your ecoregion to find the top 10 birds, as well as bird focal species. For instance, if we click to the Foothills Top 10 Birds section, we find the oak titmouse are the most abundant species, followed by ash-throated flycatcher. If we scroll down below the top 10 species, we can see figures of focal species abundance over time, separated out by habitat preferences. These figures show data from the same set of monitoring points for each sampling event, making this an equal comparison over time. If we scroll further down to grassland focal species of the foothills, we can see that western meadowlarks seem to have increased over the last decade, which is quite interesting and a trend we are currently investigating further. And while you're doing a tour of the bird data, don't forget to listen to a bird recording for your ecoregion, which can be found at the bottom of each ecoregion description section. We'll take a moment to listen to the iconic song of the western meadowlark, which many of you have probably heard out on the rangelands.